Good morning, dear Shem stars. How are you all, students? I hope you all are safe at your home. Students, today we are starting with the topic of derivatives. In derivatives, first let us know what is a derivative. The derivative of a function of a real variable measures the sensitivity to change of a quantity, a function of dependent variable, which is determined by another quantity, the independent variable. Students, here we are talking about dy over dx, where x is the dependent variable and y is the independent variable. For example, the derivative of the position of a moving object with respect to time is the object's velocity. So that is dx by dt. This measures how quickly the position of the one object or that object changes when the time is advanced. So that is the velocity of an object, that is given by dx over dt, that is change in distance over per unit time. Now some of the formulas which are based on the derivatives. The very first and very important formula is the power formula, that is derivative of x raised to power n with respect to x is given by n x raised to power n minus 1. Similarly, the derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of tan x is secant square x, derivative of cot x is minus cosecant square x. Next, the derivative of secant x is secant x tan x. Derivative of cosecant x is minus cosecant x into cot x. Derivative of a raised to power x, that is constant raised to power x, is a raised to power x log a. Next, the derivative of e raised to power x is just the e raised to power x. Then derivative of log x is 1 by x. So students, these are very important formulas which will be required to solve the exercise 13.2. Now, how to find the first derivative? Its formula is given by f dash x is equal to limit h tends to 0 f of x plus h minus fx over h. You just need to remember this formula where f of x plus h is the small change minus fx, that is the original function, divided by h. So we are going to apply this formula in many questions. So let us see few examples based on this formula. First question of exercise 13.2 is find the derivative of x square minus 2 at x equal to 10. So let us solve this question with the help of the first principle. Now here the function is given as, that is f of x as x square minus 2. Now here we have to check when x is 10. So that means its change is a is equal to 10. Now f of a plus h will become f of 10 plus h, that is changing x to 10 plus h. That reduces to 10 plus h whole square minus 2 from the function. So on simplifying this, we will get it as h square plus 20h plus 98. Now f of a, that is f of 10. Substituting x as 10 in the fx, we will get it as 10 square minus 2. That is 100 square minus 2 is equal to 98. Next, we know that f of a is given by limit h tends to 0 f of a plus h minus fa over h. So that means f dash first derivative at 10 will be equal to limit h tends to 0 of f of h 10 plus h minus f of 10 over h. Next is to substitute the values. So that is limit h tends to 0, h square plus 20h plus 98 minus 98 over h. That reduces to limit h tends to 0, h square plus 20h by h. H is common in the numerator, so we will take it out. Cancel both the h from numerator and denominator. So we will be left with limit h tends to 0 of h plus 20. That is equal to 0 plus 20. Hence our final answer is 20. Hence the derivative of fx at x equal to 10 is 20. I hope you have understood this first principle. Let us see one more example based on it. Example 3 is find the derivative of x at x equal to 1. So here fx is given as x and a is 1. Now f dash 1 by formula is given by limit h tends to 0 of f of 1 plus h minus f1 over h. Here we are directly substituting this value. So that reduces to limit h tends to 0 1 plus h minus 1 over h. That is limit h tends to 0 of h over h. Both will get cancelled. Hence limit h tends to 0 of 1. That is 1 only. Now next two questions you just try by yourself, students. From tomorrow we will be discussing from the question number 5 onwards.
That's all for today, students. Do revise what we have done in the class. And if you have any query, please feel free to ask on the Google Classroom. Take care and have a great day ahead.